Okay, in this video, we are going to learn how to CUSS and BS data. And what that really means is we're going to develop a common language for learning how to describe quantitative data. Now, in this particular area, we're going to learn basic shapes. We're going to talk about all sorts of things. And I have to say this video is going to be a little bit longer than I normally like to make. So, CUSSing, obviously it's an acronym, and although it starts off saying measures, the CUSS stands for center, the C stands for center, which happens to be the measures of the middle, which are the mean and the median typically. U is unusual features, which our unusual features are gaps, clusters, and outliers. S is shape, which can be skewed left, right, mound, symmetric, uniform, bimodal, or multimodal. And the other S is for spread, how much variation. And by the way, spread and variation are essentially synonyms for the same thing. The measures of spread or variation are the range, the interquartile range, variance, and standard deviation. And there's a difference between variance and variation. Variation is basically a synonym for spread. Variance is actually a calculated measure. All right, so when we also said that we're going to BS, and BS means we need to be specific, which means if we're making comparisons, we need to make very direct comparisons, very specific comparisons, and where possible, we need to give numerical values. All right, we would actually need to measure, say where our center was numerically. We would need to give how much spread there is. Okay, so when I know students always want to know, do I have to do these every single time? And the answer is yes, but I will give them a ranked importance. Center and spread must always be addressed. Failure to do so is going to get you no points. Shape, if you want to receive full credit, you will be discussing shape in some form or fashion. Unusual features, you must talk about if they exist. They're not always going to exist, and if they don't, you don't have to address them, but I recommend that you just get in the habit of saying no unusual features if none exist. So looking at the center first, we said that's measure of the middle. We talk about the mean, which we've already discussed in a previous video, which is the average of all values. In other words, we sum them all up and divide by the sample size. Since we include all values, that means we're also including outliers. Consequently, the mean is greatly impacted by outliers or non-symmetric distributions, as the case may be. The mean is also a balance point on a scale or a seesaw. So basically, if we had a seesaw and we said something like this, and we put a fulcrum here, and we had a really skinny person, stick figure, put some hair on them, or we have a really much heavier person over here. All right, the balance point would occur right here, and this would be the average. It's not actually in the middle, it's just the balance point. Okay, the median is the one that's exactly in the middle, so that's our next one. The median is exactly halfway between. If you put everything from the order from least to greatest, 50% of the values will be larger and 50% are smaller than the median. Unusual features. And you know what, I should say this right now. Although it's listed together as CUSS, center, unusual, shape, and spread, it doesn't matter the order you address them. Usually I address them by whatever is most obvious to me initially. So I just start with what's there. If not, you can use this, but it's just a good way, mnemonic device to remember things. So back to unusual features. So the first one we talk about is a gap. And a gap is basically in the distribution, we come to a place where there is no data. If we have no data, then we have a gap. Usually that's only like one or two spaces. The next thing is clusters. Clusters is when we have two groups of data, or there may be two mounds. If we have clusters, if we have clusters, you need to make sure that you describe the center and shape and spread, especially the center and spread, for each cluster. In AP statistics, we're going to look at two different methods of determining outliers. All right, I'm going to drop down to number 2 first because we talked about this in the previous video. And basically we said if something was more than 1.5 quartile ranges below the first quartile, it was an outlier, which really gave us the formula X, if X is less than Q1 minus 1.5 IQR, it was an outlier. And also, if it was greater than the third quartile plus 1.5 IQR, it was also an outlier. We are going to, in this particular unit, we're only going to focus on this method of calculating outliers. This is probably more preferred by the colleges. This is probably more preferred by AP statistics. Number one, we will be looking at, and we will use it a lot when we get into probability in November, but it'll be in November that we talk about it. But basically, it's going to be, we determine an outlier by taking the mean, whether it's X bar or mu, plus or minus 2 standard deviations, or X bar plus or minus 3 standard deviation, wherever we want to set it at. So that's what it sounds, but we're not going to, you don't need to know this for this unit. We will discuss that in detail on probability. Number 2, right here, got to know. It's going to be a very big deal for this particular unit. Okay, so shape. We have lots of determinations for shape, and basically some of these shapes will fit into more than one group. So if a shape is symmetric, that means we can divide it into half and getting matching mirror images. And if I drew a vertical line here on each one of these, you can see that they would fold over on each other and get a mirror image. Something else that's going to be very important to note is that the mean and median are the same for each one of these. And in fact, I could even have something that looks kind of like goalpost, where all my data is on the ends. I have no data in the middle, but once again, it's symmetric. So the mean and the median are the same, even though there are no data points in the middle, because once again, a mirror image describes it. If you'll notice, this drawing is in the same spot both times. And this is a uniform, but it happens to be symmetric, because if I cut it in half, it's a mirror image. And a uniform is a graph that's approximately the same height. And by the way, remember, we're working with data, so when we say something, it's like it's approximately, it's somewhat, it's close, it's reasonably. So we like to couch it a bit. And my best example of a uniform distribution would be rolling a dice. So if I roll a dice, the probability of getting a 1 is 1/6. The probability of getting a 2 is 1/6. The probability of 3 is 1/6. 4 is 1/6. 5 is 1/6. And finally, the probability of getting a 6 is 1/6. So essentially, we're about the same height all the way across. So consequently, that would be a uniform distribution, and that's just rolling a dice. Here we see we have the same one as we had before. So this is obviously symmetric. And people want to say, or students often are tempted to say that this is mound shape. I mean, to say that it's normal. Normal curves are mound shaped, but we don't know if this is a normal curve, so don't call it normal. We're either going to call it mound shape, or if you prefer, you may call it bell shaped. Because there are a lot of curves that are shaped like this that are not normal. They just, so don't say that, don't say approximately normal, just say it's mound shape or bell shape. Well, once again, It's symmetric. We already said that. And we know that the mean is equal, and the mean and median are equal here. But not only are the mean and median equal, the mean, the median, and the mode are all equal. And you're like, well, he hasn't even talked about the mode. Well, the mode is the part that occurs most often. And since this is the tallest part, it's the part that occurred most often. So this one is mound shape, and all mound shaped curves are symmetric. They are all, and in all cases, the mean and the median and mode are the same. That's not the case up here, because the mode, that's the mean and median are the same, but the mode is not. The mode is going to be out here on this one. All right. This next shape is skewed. We're going to talk about skewed, which is extremely important. And so please pay careful attention. Really important you get to get a handle on this. And by the way, when it comes to skewness, students go, hey, can that be skewed left or skewed right and skewed right? There's no such thing. It's either skewed left or it's skewed right. It cannot be both. So skewed left, the tail is to the left and the mean is less than the median. So I like to think of a piece of sticky water gum, and I put it on the ground and I pulled it, I stretched it off to the left because it looks like I'm stretching it this way, right? It looks like I'm stretching it this way. I'm stretching it to the left. So this is going to be called skewed left. And the median probably occurs somewhere around here. So that's the median. Well, because it's skewed left, the mean will be to the right of it. So the mean is to the right of it. And if I were to add a number line, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, we see that the mean would be less than the median. So you need to get that. The mean is less than the median. So here's a couple things to remember. If it's stretched, if it's skewed to the left, it's stretched to the left, and the mean is to the left. The mean is to the left if it's skewed left. Okay? Skewed right. Well, basically, we had that same wad of gum. We stuck it on the ground and we pulled it or stretched it to the right. All right? So it's been stretched or pulled to the right. And if our median occurred here, then our mean will be to the right of it. So in this case, we put a number line 0, 1, 2, 3, 4, 5. We see that the mean is greater than the median. Very important. So skewed left, mean is to the left. Skewed right, mean is to the right. Okay? Bimodal. And bimodal distribution just means that you have two peaks. In this particular instance, we happen to be symmetric and mound shape. Doesn't have to be. My mode occurs here at the two peaks. And if you have a bimodal distribution, you must always tell me where the peaks are. This is also a bimodal distribution, but it's not symmetric. And once again, if I had a distribution like this, you should tell me where the two peaks exist. Okay? All right, moving on to spread. While this page is very long, I'm going to go through it fairly rapidly, which means you're probably going to need to make note, come back and read this very carefully to yourself. So when we talk about measures of spread, we're really talking about variation. And that just means how much does how spread out is the data, how varied is the data, or how far away, and there are different ways of calculating this. So one that you probably learned in elementary school, at least by middle school, is the range, which is basically just the largest value in the data set minus the smallest value. The range is greatly impacted by outliers. Why? Because if the largest value is an outlier, it included it. If the smallest were an outlier, it included it. And please note, the range is a singular value and is never negative. All right, it's a singular value. It is the result of that equation. All right. The interquartile range, which we talked about in detail on another video, is basically the range of the middle 50%. Well, keep in mind that IQR, or the interquartile range, equals Q3 minus Q1. Well, Q3 is 75%, and Q1 is 25%. And if I subtract them, I get 50%. And that's why we say it's the range of the middle 50%, because essentially this is larger and this is smaller. So it's the range of the middle 50%. Obviously, we're not looking at we're not looking at the lower 25% of the data, and we're not looking at the upper 25%. We basically ignored the ends. Well, if we ignored the ends of the data, that means we're not impacted by outliers. The IQR is not impacted by outliers. Variance. Please note this word is different than variation. Variance has a specific formula. And I don't want to spend a whole lot of time on this, but I'm going to relate it to standard deviation. So we talked about standard deviation in a previous video. And if I take the square root of that, I end up getting this. And if I take the square root of this, oh, it's like, hey, that's the standard deviation formula. So variance is just basically the standard deviation squared. All right, variance is the standard deviation squared. And the reason the variance is basically each individual value minus the mean. Variance is impacted by outliers. Why? Because outliers are used to calculate the mean, and if there is an outlier, then it will be used as an individual data point. Now, when I say when I said that outliers are used to calculate the mean, I should have said all the data points were summed together to take an average. Consequently, if there were outliers, they were included in the data. So consequently, because they're included in the mean, they're going to be included in the variance. So it's going to be impacted by outliers. That said, we rarely ever talk about variance. Variance is something that used to be done a long time ago, and the main reason is because they weren't able to take square roots on a calculator. They had to do them by hand. We much prefer to talk about standard deviation, and standard deviation is just the square root of the variance. You'll notice this formula is the same as this one, but we just put a square root sign over it. And once again, the standard deviation is the average distance from the mean. And once again, this is also often, is impacted by outliers. We have a different standard deviation formula for samples versus populations, but this is not something you need to memorize. Just this is a point in fact. Something they may discuss a little more in the college stat class. Here in AP statistics, it's not really discussed that much, just making you aware. Z-scores. Z-scores are extremely powerful. And although they actually fit into this unit, we're going to wait to probability, just because it seems to work much better for the way students perform. And we get to spend a lot more time with them because they're necessary for probability and you'll use them at that point. Whereas here, it's just kind of an interesting factoid. So we're not going to spend a whole lot of time on it in this unit. Matter of fact, you won't be tested on it this unit. Well, first off, Z equals X minus mu over sigma. Well, what does that mean? X is the individual value minus the mean divided by the standard deviation. And basically, it's just a ratio that takes into account both the center and the spread or dispersion of the data. And they act as a ruler so that you can compare different shape values. It's really incredible. You can do a Z-score for any type of distribution. And The Z is the actual, tells you the number of standard deviations something lies from the mean. So the bigger the Z-score, the farther the way it is from the mean. A Z-score of 0 means it's actually at the mean. And it takes into account the spread of the data. This is an extremely powerful tool, but we will wait till talk about it in probability. All right, thank you.